Wing's approach has been to develop what are called these sort of separate lift and thrust vertical takeoff and landing airplanes. So, rather than having tilt rotors or having the whole airplane tilt over or having, like a tilt wing or other different moving parts of the airplane, there's basically sort of drone components mounted onto a sort of more conventional aircraft.
What is the future of drone delivery? Drones are at the epicenter of 3 or 4 tech megatrends that I follow: smart matter, automation, AI, and decentralization. Alphabet portfolio company and Google sister company Wing is at the forefront of drone delivery. Wing has made over 250,000 deliveries in the US, Finland, and Australia. They have a unique take on how to develop the business and where it fits. To chat, we've got Wing CEO and former CTO Adam Woodworth. Welcome, Adam.
Hi.
Let's start big picture. Why do we need drone delivery? Why is it important?
Wing and drone delivery more broadly is really about sort of removing the elements of friction from the current transportation ecosystem. So when you think about it today, like people order lots of stuff every single day. Every single day people are ordering things, getting delivered. Right now, like you're moving single pound packages in multi-thousand pound vehicles, and like there are just more efficient, lower impact ways to do that. And Wing is fundamentally about bringing that, like eliminating that friction and sort of bringing that vision to reality.
I got to say, I've got a neighbor and there's an Amazon truck there every single day. So I know exactly what you're talking about. Crystal ball, really briefly, how big does drone delivery become? What percentage of last mile deliveries do you think it could eventually take up?
I firmly believe that like delivery will always be multimodal. Like you're always going to have, multiple different ways to go and move boxes. If you take the example and extrapolate to a car, like if I need to move around, a couple tons of gravel, I'm going to like rent a dump truck. I'm not going to put it in the back of a four-door sedan. In the same way, like there are a lot of goods that fit really well into sort of the capabilities that that we've developed, and there are some goods that don't. Like we're not going to be delivering refrigerators anytime soon. But I think that the vast majority of goods that folks order on demand today can very easily be served by a drone delivery capability.
So you've got a little bit of unique aircraft. You've got sort of fixed wing aircraft that are also drones. Maybe I'm using the wrong terminology here. Why are you building your drones that way?
Yeah, I mean, so I brought a little visual aid here to help. But, at the core of it, drone delivery poses the challenge of, you have to go and bring the goods right to the customer. And, vertical takeoff and landing aircraft are very much the easiest way to do that, right? So you have, the ability to sort of slow down to a complete stop, hover down over the front yard or the backyard and lower the package sort of like smoothly and safely to the customer. Hovering vehicles are typically not very efficient. So, they like, the trade that you make for the ability to hover and maneuver like that is that you're limited in how far you can fly. And so Wing's approach has been to develop what are called these sort of separate lift and thrust vertical takeoff and landing airplanes. So, rather than having tilt rotors or having the whole airplane tilt over or having, like a tilt wing or other different moving parts of the airplane, there's basically sort of drone components mounted onto a sort of more conventional aircraft. So if you think about it, the airplane will hover up to altitude and then in the same orientation sort of accelerate until it's cruising like an airplane. And you effectively have like an infinite runway. Most airplane wings are sized around like sort of how you can take off and land on a relatively tight space. By eliminating that, by sort of being able to just like already be lifting the airplane, accelerate up until the wing is providing all the lift, you can have an airplane that's just optimized for cruising. So if you look at our planes, like the wings are relatively small because they're designed just for that cruise phase. The one other benefit of this that's relevant is that you're effectively carrying around like a redundant airplane with you. So, I'm flying around like a plane. If anything, breaks on the airplane side, I'm carrying a helicopter with me so I can sort of revert to helicopter flight. Our system has the ability to sort of spill over control. So like if this aileron over here isn't generating enough roll, these motors can help it. But essentially, if you think about it like robotics, and you have 6 degrees of freedom, and then you have a bunch of different forces you can apply, we're a super overactuated system. Like we have a huge number of different actuators that we can use to control
that. Is super smart. I mean, I didn't even think about that in terms of your wing surface area, that, a typical plane has to have enough wing surface area to generate enough lift at very low speed. You don't have that problem. And you've got multiple backups and safeties in case your main propeller dies or something like that. Now, you're releasing something that you're calling the aircraft library. What is that?
We've been operating commercially for several years. As you said, we've accumulated, several 100,000 commercial delivery cycles. And that has all been on sort of the core of our aircraft fleet called the Hummingbird aircraft. So like this airplane, most of the airplanes that you've seen from Wing look pretty much like this. Maybe, some colors have changed and the wings have gotten a little bit bigger, but largely look like this. And we've heavily invested in sort of the core architectural elements of this. So like the avionics unit, the sort of brain that lives on the back of the airplane that sort of tells the airplane where to go and sort of how to control it. The propulsion system elements for hover that hold the airplane up in the air, we need like a higher level of reliability on, the sensing to tell how fast the airplane's going, the battery and the battery management system, all these different elements, we've accumulated an immense amount of operational flight time on. We've accumulated an immense amount of test time on, and they're really robust, really capable sort of like building blocks of the system. The airplane is sort of a wrapper around that, right? If you think about all those elements as construction bricks, like we've happened to build them in this shape of a plane, but we could disassemble that and put them all back together and make it look like a rocket ship, or make it look like a steamboat. Like the sort of core element here is that a lot of the elements that are sort of core to the functionality of the system, core to the reliability and performance of the system, those can be adapted to different use cases. So, what we've done, these aircraft have been going and delivering packages to people every day for the last several years. Our R&D team has been sort of like spinning up the flywheel of, okay, using some of these common architecture components, what else can we make? Like, what if we, this airplane was highly optimized around carrying a, 2.5-ish pound box. And, if you go to an airport and you look out on the runway, like all the airplanes look different. You got big airplanes, you got little airplanes, you got airplanes with 4 engines and 2 engines. And like, that's because they're all designed for very specific functions. So in this case, this airplane was designed to carry about 2.5 pounds of stuff and carried about 6 miles. What if we wanted to carry twice as much stuff? Well, you probably need a different looking airplane. What if you wanted to carry, a third as much stuff? Well, then you probably have too much airplane here. And so what we've done is started to spin up that development flywheel of sort of building out different aircraft configurations that we bring to sort of like an advanced prototype level. We solve a lot of the sort of hard engineering problems associated with the new configurations, but we don't have to build a new avionics. We don't have to build sort of new motor controllers. We don't have to build like new battery management systems. We can leverage the hundreds and hundreds of thousands of flights and sort of all the testing hours and all of the confidence we've built in those systems. And that provides a level of sort of future flexibility that's really interesting in this space. Right now today, we focus mostly on the sort of stuff that people are ordering through on-demand delivery services. So a lot of prepared food, a lot of small household items. But by going bigger, you can. What if I want a pair of sneakers? What if I want a cordless drill? Like you're going to need to build a different capability to do that. And then similarly, what if you want to go smaller? What if the genesis for the smaller airplane, and we're sort of leaning into the library analogy here. So the small planes called Article 1, it's like the sort of first volume in the library. Big planes Article 2. We've got a number of different other articles. But on the small aircraft side, what if you're just delivering the bottle of prescription medication? What if you're at the job site and you open up the toolbox and like you are missing one hex key? Like what's the these sort of like truly sort of like on-demand necessary items that may not be that big. This airplane is optimized for carrying bigger stuff, and you can sort of re-optimize it for carrying smaller stuff. So those are the threads that we've pulled on, and that's just sort of the items that we've shown most recently represent the sort of payload space there. So starting from the middle here and then going, sort of bigger to one side and smaller to the other. There's other dimensions that we're also exploring. What if you wanted this plane to go, 5 or 10 times as far? What if you were only operating inside of a city where you don't need to cruise? You're just hovering all the time. Sort of what are the different design decisions you make there? And we're sort of building up the team and the process and like the methods to go and rapidly churn through these.
It's fascinating. Designs. It kind of reminds me a little bit of software development, where you've got modules, or you call in an API or some libraries of code or something like that, and that's known good, and you can call that in and use that. You componentize, and then you put together the components as you need and add a little custom flavor, and there you go. You've got something new. That makes a ton of sense, and it gives you the capability, like you said, maybe you want a rural one that's going to fly, 20, 30, 40, 50 kilometers or something like that, right? But in the city, you don't need to go that far. How is this going to help you? What does a wing, I don't know if I call it an airport or a wing facility.
We call them nests.
Okay, I like it. Nests. Excellent.
Nest.
How does a wing nest look like 3-4 years from now? Do you have 4 or 5 different styles of airframe there?
Yeah, I mean, I think, part of the reason for this exercise is that like no one element of the system is really the answer. It like I think for drone delivery to really work, it's about sort of all of these pieces coming together and sort of like seamlessly integrating into the businesses that we serve and sort of the customers that we serve. In the same way that we've looked at the aircraft development in terms of like what are the sort of core elements that like we invest a lot of like time and effort in sort of getting highly optimized, but a focus on being able to sort of rearrange them into different configurations. We've taken the same approach on the infrastructure side. So my little visual aid here does not have the charging pins on the bottom, but on the bottom of our aircraft there's 4 sort of spring pins, and the airplanes land on big giant circuit pads, the circuit board. So it's like a 3-foot square, big printed circuit board that's got positive and negative lines. And the foot on the bottom of the airplane is designed so that the plane can land in sort of any orientation on that and charge. And so, somebody doesn't need to go out and put the plane in the right orientation. Somebody doesn't need to go out and swap batteries on the airplane. Somebody doesn't need to go out and like sort of, tell the airplane, okay, it's time to like, go take off and do a mission. The infrastructure sort of has to be sort of similarly simple and similarly modular to sort of enable these sorts of features. So, if you look at our, some of our more recent deployments in Australia, we put our nests on the roof of a shopping center, and at our most recent deployment in Dallas, the nest is actually in the Walgreens parking lot. And it's sort of as simple as like put down the pads. Like all you need is enough space to put down pads and a wall outlet to plug the pads into, and then sort of the airplanes connect to the internet on their own, and like that's the sort of level of setup that I think the future necessitates. And so to your question of what does the future of a nest look like, I think that you'll see lots and lots of these collections of pads sort of like distributed around cities and communities, and very likely there'll be planes that look just like this one on the pads, and there'll probably be some plane that looks different from this one on the pad. And there may be sort of a different mix of those. You might have a lot of these planes and like just one of the long range plane or just one of the big heavy plane. But I think that like back to the thesis of, delivery is always going to have the need for sort of, solutions optimized for the things you're carrying around. And I would fully expect that, for that big nest that has most of these planes and maybe some other planes, like there'll probably still be a delivery truck that shows up at the store and picks up the refrigerator, because that's what the delivery truck is best at. And for the bottle of medicine that needs to get delivered, or for the cordless drill that needs to get delivered, it'll go on something.
Super
like
fascinating. And I assume in the future there'll also be algorithms that optimize where what planes go to which nests in a city. Certain ones are busy overnight for the midnight snack, right? Certain ones need more during the day as people go into their workday. And as you mentioned, you're on the job site, you need that hex key, and you can't complete your $1 million job without that one hex key. And other ones are needed more at lunchtime and supper time. Super, super interesting. What are the critical technologies that you've had to master to get Wing to where you are today?
Yeah, I mean, I think sort of at the core, the sort of avionics unit, the sort of brain of the system that lives on the back is like that's the core of all of this. So the flight controls that adapt to sort of changes in performance to the system, the sensing systems that sort of as you go and do the delivery, sort of make sure that the plane's in the right spot, even if you don't have GPS, even if it's really windy, even if it's really rainy, building up the sort of reliability and the functions of that unit, and sort of all of the like all of the heuristics associated with it. Like every flight we do today, like the system learns more about itself. So right now today, if a plane is flying and it comes back and it says like, hey, I was carrying like some more roll control than I usually come back with, like it tells the maintenance staff like, hey, like go look at this plane and like check out the aileron. And like those are the sorts of capabilities that sort of like the system gets iteratively better the more and more you operate it. Like the more you fly, the sort of more automated it gets. The more automated it gets, the more you fly, and like the sort of more the system knows about the health of itself. And I think that as you see these operations expand, it becomes a positive feedback loop, and that's the part that I think is really, really compelling about these sorts of use cases. So the avionics unit on the back, and then I think a lot of the development around sort of the hover propulsion technology, particularly some of the rotor design work we did to sort of mitigate noise generated by the rotors, and just generally building a really, really robust power system so that like you sort of can always count on those pieces of the system. From a hardware perspective, those are the sort of really core elements. The sort of other one is like how you physically build these. So like a lot of airplanes are like fully molded out of composites, and the cost of materials is really high. And our plane, we've done a lot of work to really optimize around sort of how you build a lightweight, high performance, high reliability system with sort of like truly off the shelf components, particularly on the sort of airframe side. So the carbon spars that are the sort of main elements on these booms and through the wings. Like a lot of the design decision, a lot of the reasons why this airplane looks the way it does is that intersection between sort of performance, cost, and sort of those two things working together to always sort of meet the safety and performance numbers. So like really optimizing the airframe design and really doing it in a way where you can build a lot of them, you can sort of build them all cost effectively. Like that's something that a lot of thought and time has gone into, and that
makes a ton of sense. I mean, if drone delivery gets as big as we think that it could, you will need millions of these, and you will need to design these, and order 10,000 at a time, for a new city you're bringing online. That's significant. The question that I've got is what remains to be solved? Is it largely regulatory problems and I guess the operational problems of getting a city or a region up and running, putting the nests in place, getting businesses aligned and saying, hey, I want to try this out, getting consumers used to it and knowing that it's going to arrive this way? What remains to be solved?
Yeah, I think that is that's the question I ask myself sort of every day is sort of what are the things that are still to do. One of the elements that Wing has sort of built most of our sort of design and engineering philosophy around, and sort of our company philosophy around, is like building to performance-based standards, building to sort of like outcomes, right? And I think that if you look at things from the regulatory perspective, the places where sort of the most progress is being made is where, that is the focus. So sort of building the rules, building the approaches, building the building the certification standards, like to be impedance matched for the types of systems that you're assessing. And so, matching the performance of the system to the sort of, like types of frameworks it fits into. And so I think that like we're seeing a fair amount of that sort of globally. We're seeing sort of more countries adopt sort of similar, similar approval frameworks. And sort of it's just like you just need more of that sort of more frequently. It's like those are examples where things are working really well. And I think the sort of to the other element of your question, this has largely been an industry of what ifs for a very long time, right? So like people have been talking about what drone delivery might look like. People have been talking about all the different use cases for drones, but it's only sort of relatively recently that there's operations at a meaningful scale. There's a handful of companies doing a sort of a meaningful number of flights every day. And, for a space of what ifs, like doing is the ultimate cure for those what ifs, right? Like, I can't sort of like, I can't even think of all of the conversations I've had over the last, long time about what this might look like or what this experience might be like. And there are now communities that this is like very real for them. They see it like every day. In some of the communities we operate in Australia, it's like, every day people order things. For that region, it looks like scaled out drone delivery. And a lot of those sort of what ifs have been sort of proven true or false. A lot of new hypotheses have been formed, but I think the next real step there is sort of what are the unanswered questions on that front that like we will only experience through doing. And I see that as, right now today, the industry is still largely talking about sort of the next neighborhood or the next city. What about the next state? What about the next country? What about like we're seeing sort of the expansion flywheel start to spin up. And I would expect to see sort of like each one of those increments becomes bigger. And, as you do that expansion, you'll learn more about sort of, how a more distributed system functions at a scale like that. You'll learn more about sort of how you're sort of like really deeply integrating with partners around the world that are providing the goods that you're delivering with these aircraft. I think that's the sort of the next unknown is the most exciting piece, which is like, as you get to this next level of scale, what are all the things that you thought that were going to work that do work? And then what are all of these new opportunities, new learnings that sort of unlock more opportunity in
Absolutely.
in this space.
Lots of tough questions remain, and honestly, discussion, at least for me, and I know many others, not everybody's crazy about lots of drones flying around their neighborhood, but for many, I see what's going on you're in, I think, a couple markets in Australia, you're in Finland, I think you're now in 2 markets in the US, and we look at that and say, okay, when's it coming here? When can I order a hot coffee? And boom, there it is, 2 minutes later type of thing. Of course, that remains to be seen, and there's complex answers to that. Anything you could tell us about expansion plans?
Yeah, I think more most broadly, sort of the discussions have moved from the if to the when, and that's like a big deal, right? Like I think that we're at this inflection point as an industry where it's like we've reached sort of like critical speed on the flywheel, and it will keep moving. Like sort of, you will eventually get the service. To some of the points I talked about before, as we continue to grow, sort of starting to look at sort of regional expansion versus like city to city, sort of statewide expansion, sort of looking at sort of like how you go across a much larger region than we operate in today. I think that those will be the sort of next steps. And, ultimately you get to these frameworks where rather than looking at like, okay, this is the one outline on the map, like how are we going to go open up a service there? you start looking at the sort of characteristics of the map, and it's like, okay, like sort of like these population densities, this type of like terrain, like you start looking at it as like this type of airspace you're operating in. You look at it as the characteristics of sort of the environment, and sort of if one looks like the other, it's sort of like by like, and then that expansion happens more organically.
I think so as well. And one thing I look forward to is kind of what I call the drone Pony Express moment. And I know that this will never really happen as a matter of course, but I kind of wonder about that transshipment. Something's coming from, let's say, LA and it's going to New York or something like that, and it's going entirely by drone, and it's going in from one to the next to the next to the next. That'll be interesting to see. I have no idea when that'll be, if that'll be 10 years or 20, or or maybe never. I'm not sure. There's some vast distances across. In any case, super interesting. Thanks for sharing about the drone library and some of your plans. Appreciate your time.